The lesson outcome for this video is, I can factor a quadratic expression when a equals 1. Now I'm going to get a lot deeper into this topic and the ideas behind it, like what is exactly a quadratic expression and what does it mean when a equals 1 and how is it different when a is not 1. All of these things are going to be answered more so in class. But today in this video what I would like to do is just simply teach you a process that you're going to use and that we're going to talk a lot about in class. So let's say I have x squared plus 3x plus 2. Okay? This is a trinomial, as we know because we've been working on that in class. 3 terms, 1, 2, 3. We know that the leading coefficient right now is 1, and that's where this comes into play. We'll talk about that in a second. And then the degree of this is 2, which is what makes it quadratic. Again, more on that in class. But what we're going to do is we're going to do a process called factoring. Now this is different than factoring out a GCF or a greatest common factor like we've done. It's a different type of factoring. And what it is we're trying to find out what 2 factors that would be binomials in parentheses, okay, would multiply to give me this trinomial. Okay, so the process is going to be this, and I'm again mainly going to talk about the process and we'll talk about why we do it and why it works in class. So first thing I want you to know is that the number or coefficient in front of the x squared term, so our leading coefficient, is what we're going to call a. And then the number that's in front of x is what we're going to call b. And then the number that is the constant, that is by itself with no variable, is what we're going to call c. Okay? Now what we're going to do is, right now we're going to make sure that a is 1, which it is, and that's this process with a equals 1. And then we're going to use our b, the number in front of x, not including the x, but the number in front of x, and we're going to use the c to help us fill this in. And the way we do that is this. We are going to write our constant, our c value, so 2, okay? And then we are going to, I usually like to put a little rectangular box around it. We're going to write below that every factor of 2. Now that's a pretty simple one at first, okay, because 1 times 2 are the only factors of 2. All right, then what we're going to do is we are going to check b. And what I mean by that is we are going to add the 2 factors that I've listed here, 1 and 2, and I'm going to find out if it equals our b value. So what's 1 plus 2? Well, it's 3. Is that our b value? Well, yes, it is. Our b value is 3. So because it's equal to the right b value, we know that these 2 numbers right here are what we are going to use as our factors in the parentheses to the left. Okay, so what we're going to do now in these parentheses is the first thing we're going to do is we're going to write an x here and an x here. And the reason we're able to do that is because we know if we were going to FOIL this, remember FOIL, first, outside, inside, last. If we were going to FOIL this, x times x is x squared. Okay? And now what we're going to do is we're going to put these 2 numbers, 1 and 2, we're going to put them in here and in here. It doesn't matter what order you put them in, but I'm going to put the 1 and then the 2. And then since those are 2 positive values right here, we're going to put a plus in here and a plus in here. And what we have just done is called factoring a quadratic. We found out that this binomial times this binomial will get us this trinomial. Now, we're not going to do this every time, but what we can do to double check that we have arrived at the correct answer is we can use our array or our FOIL method to check that when we multiply x plus 1 times x plus 2, like in our previous unit, we get x squared plus 3x plus 2. So I'm going to do that right here. I'm going to write my x plus 1 here and my x plus 2 here. And remember, using the array, we're going to go x times x is x squared. We'll put that right here. And we know that 1 times x is 1x. And we know that x times 2 is 2x. And we know lastly that 1 times 2 is 2. If I were to write our factors, x squared plus 2x plus 1x plus 2, and then combine like terms, x squared plus 2x plus 1x is 3x plus 2, notice we have now arrived at the problem we started with, or the expression that we started with. So we know that these two factors do indeed multiply to give me this, and that is called factoring. Okay, let's try another example. Again, it's probably going to help if at the beginning of these problems we get used to writing A, B, and C so that we can see what our coefficients are. Okay, A is 1, the number in front of x squared, B is 11, and C is 18. Now remember, what we start with is we start with our C term. C in this case is 18. Okay, now what we want to do is list all the factors of 18. We know that's 1 times 18, and I always start with just the 1 and the number that it is itself. And then I divide by 2 in my head. I'm like, yep, it's divisible by 2, so I'm going to say 2 times what gives me 18, and that's 9. And then I'm going to go to 3. Is 18 divisible by 3? Yes, it is. It's 3 times 6. And then 4, it's not divisible by 4 or 5. So we have all of our factors of 18. Now what we need to do is, again, look for the factor pair that adds up to our B value. Okay? So does 1 plus 18 add up to our B value? 19? Nope. Does 2 plus 9 add up to our B value? Well, 2 plus 9 is 11. Yep, it does. This 11 right here matches our B value of 11. Just to check our last one, 3 plus 6. What's 3 plus 6? Well, that's 9. 9 is not our B value. So we know that our B value of 11 was arrived at by using 2 and 9. Okay, so again, what that means is we can go ahead and put 2 sets of parentheses down here. The first part, whenever A is 1, like it is here, we know that an x and an x will be able to go in our parentheses because x times x is x squared. And then we have a positive 2 and a positive 9. And again, we got these two numbers, 2 and 9, from right here because they added up to our B value of 11. If we were to FOIL this or use the array, we would arrive back at this. So we have now factored our quadratic. Okay, let's try this example. This time, again, we have our A value, leading coefficient is 1, our B value is negative 10, and our C value is positive 24. So remember, we always start by writing our C value, 24. Okay, so what are the factors of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. And now the question is, how can we get our B value when we add them, right? So does 1 plus 24 give us our B value? Well, 1 plus 24 is 25, so nope. How about 2 plus 12? Well, 2 plus 12 gives us 14. Nope. 3 plus 8, well, 3 plus 8 is 11. Nope. And 4 plus 6 is 10. Now, that's almost a yes, but it's kind of a no, because notice, what is our B value? Negative 10. Negative 10, not positive. So, how can we get a positive 10? I'm sorry, a negative 10, where we need that to be a negative 10 for B. Well, if you think about it for a second, there's another set of factors that when multiplied give you positive 24. Can you think of what that might be? Well, the set of factors is negative, and a negative. If we go back up to the top here, and we put in a negative with a 1 and a negative with a 24, okay, right here, what's negative 1 times negative 24? Well, a negative times a negative is a positive. So 1 times 24 is 24. Negative 1 times negative 24 is positive 24. So we can go through and put negatives in, 2 negatives, it can't be just 1, and we will still get positive 24 for our C value. We'll see what happens there is now when we add negative 4 and negative 4 plus negative 6, we get negative 10. And is that our B value? Yes, it is. We got it. So we know these are the factors we need to put in our parentheses. I'm going to put an x and an x because x times x is x squared. And I'm going to put a minus 4 and I'm going to put a minus 6 because that is my factors I got here. And again, now we have our factors of our quadratic.